main contents of this class are basic measures to prevent direct personal electric shock. Spacing and shielding measures. First of all, please think about, in addition to covering the surface of a live conductor with an insulator, is there any other measures to prevent from coming into direct contact with a live conductor? After all, we still have a lot of conductors. Conductors are bare wires, screw conductors, such as bus bars, such as high voltage transmission lines. There is no insulation covering the surface. In this case we can keep a certain distance from the energized conductor, or set up an isolation cover around the conductor when working. Set up an isolation cover or isolation barriers to separate them from people. This is also an effective way to prevent personnel directly contact with the energized body. First, look at the concept of distance. The distance is between the charged body and the ground, between the charged body and other equipment and facilities, or buildings and trees, between a live body and a live body. Necessary safety distance. 4 meanings. Safe distance between the energized body and the ground. Safety distance between charged body and other buildings and trees. Safe distance between a charged body and a live body. The safety distance between the charged body and the person is also to prevent the human body touching close to the electrified body caused by electric shock accidents. Avoid vehicle, apparatus collision, or too close to the charged body, and cause electric discharge and short circuit accidents. Here we should pay attention to, because some conductors have a high voltage level. Even if you are not in direct contact with these conductors, in close proximity to them, can still cause a short circuit to the human body, other equipment, charged body discharge. Therefore, between a charged body and the ground, between a charged body and other facilities and equipment, between a live body and a live body, between a charged body and a person, must maintain a certain safety distance, for example, overhead lines. To ensure the safe operation of the line, overhead lines at the maximum slack. The distance from the ground or water is regulated, such as 0.4 kilovolts, that is, we say 220/380ths of a volt line. From the ground in residential areas, must be 6 meters, or more to be safe. 1 kV line from the ground in residential areas must have a distance of 6.5 meters or more, to be safe, and 35 kilovolts line. Distance from the ground in residential areas must have a distance of 7 meters or more. To be safe, these 3 voltage levels are also. Usually we say the voltage level of power distribution. The concept of this Chidu explained to the students, because the wires have a certain weight, and there is a certain distance between the poles. So the wire between the poles will have overhangs, where the overhang is closest to the ground. That is, the concept of the door to say when the maximum speed, for safety reasons, without the permission of the relevant departments. Overhead lines should not cross buildings, if it is necessary to cross. The conductor and the building should maintain a certain safe distance, for example, 0.4 kilovolts line. The vertical distance between the conductor and the building is 2.5 meters or more to be safe. 1 kV line conductor and vertical distance between 10 kilovolts line conductor and building is 3 meters or more is safe. The vertical distance between the 35 kilovolts line conductor and the building is 4 meters or above is safe. The distance between the overhead line conductor and the street or factory trees also have requirements for the distance, such as 0.4 kilovolts line conductor and the vertical distance between 0.4 kilovolts line conductor and trees is 1 meter or above is safe. 1 kV line conductor and vertical distance between the line conductor and trees is 1.5 meters or above is safe. 35 kV line conductor and vertical distance between the 35 kilovolts line conductors and trees is 3.5 meters or above is safe. And when several kinds of lines are erected together, should obtain the consent of the relevant departments, and must ensure that power lines should be located above weak power lines. High voltage lines are located above low voltage lines. What is a weak line? An example will illustrate it very well. For example, the communication lines of a telephone, camera signal lines, network lines are all weak lines. For example, between 10 kilovolts and 0.4 kilovolts wires. In a normal straight line pole, the distance of 1.2 meters or more is safe. So are most common voltage distribution lines. Is there any safety distance requirements? Of course there are. Let's start with a little bit of trivia. Household wiring. From the distribution line to the customer's inlet, between the first support point, a section of overhead conductor is called the connection line. This section can be regarded as intermediate connection between the distribution line and the customer. For example, the minimum distance between the wires. The minimum distance between the wires of a house connection is generally 2.5 meters. Next is the key point of this section. In the safety regulations for electrical work, electrical parts of power plants and substations, the safety distance between personnel and the electrified part. Why is this point important? Because it is one of the elements of our course Industry Teaching Integration. There are 3 figures that we hope our students to be able to remember and understand the meaning of. There are 2 tables of safety regulations here. One is the table of safety distances between personnel and energized parts of equipment. Safe distance from the energized part of the equipment. The other is the safety distance table when the equipment is not energized, especially in AC 10 kilovolts and below, 20-35 kilovolts. This column is different. Is there any difference between these 2 tables? Personnel work with the table of safety distance between the personnel working and the energized part of the equipment refers to operating on this equipment by professional electrical staff. For example, in the case of AC 10 kV and below, the safety distance is 0.35 meter. At 20 and 35 kilovolts AC, the safety distance is 0.6 meters. The safety distance is 0.6 meters. At 66, 110 kilovolts AC, the safety distance is 1.5 meters. Here 0.35, 0.6, 1.5 meter. These 3 values are what we need to remember. This is a very important content in our study of safety regulations. Table of safety distances for equipment without power, corresponding to the reference is more broad, can be understood to mean the safety distance between ordinary workers and energized equipment, personnel who are not specialized in the operation of this equipment. At AC 10 kilovolts and below, the safety distance is 0.7 meters. For 20 and 35 kilovolts AC, safety distance is 1 meter. At 66, 110 kilovolts AC, the safety distance is 1.5 meters. Here 0.7, 1.5 meters. These 3 values also need to be remembered. Especially 0.7 meters corresponds to 0.35 meters in the above table has increased. Let's see. A case of electrocution because the safety distance did not meet the standard and caused an electric shock accident. Electricity must be operated in accordance with safety regulations. Unauthorized operation can cause accidents. Here's the story of the accident. On June 6, 2018, at about 1850 hours, a beverage store in a restaurant in Shenzhen, in the process of indoor decoration, an electrical line was found to be out of order, so the worker Guo Lon went up to the top of the beverage store to connect the line. Note that Guo was doing the electrical work alone. About 10 minutes later, another worker realized that Guo was not answering, so he went to the ceiling to check, and found Guo was lying on the ceiling unconscious, although Guo was resuscitated, but eventually died of failure to rescue. Guo was on the ceiling when he was working on the connecting line. The back of his left hand touched on an electrified bare wire connector. This led to the electrocution accident. Initially learn to analyze the causes of accidents and propose preventive measures. This is the basic ability that we require of our students. The key point is to 1. Combine the content of safety regulations. 2. Combine with our specialized knowledge. 3. Combined with the occurrence of the case. We can use the 3 elements method summarized in the course. We can analyze. Cause 1. From the safety awareness. Guo Mu's awareness of safety distance is not enough, too close to the electrified body. The back of his hand touched the charged conductor directly, because Guo is a professional electrical worker. Therefore, the safety distance between him and the live conductor should be 0.35 meters. What if it's one of our classmates? Then the safety distance should be applied. Another table, 0.7 meters, and the low light from the ceiling, was also a major cause of the accident, too technically. Lighting lines were not out of power when the electrocution accident occurred. Guo did not wear insulating gloves and other effective insulating protective equipment when working on the ceiling. Safety equipment can be categorized into the category of technical measures, free from the organization. Work colleagues did not play the role of supervision. Preventive measures can still use the three elements: safety awareness, technical measures, organizational measures. 1. Safety awareness. Electricians as special operators must establish self-protection awareness. It is strictly prohibited to rush the time and ignore the safe work system. It is strictly prohibited to rush to work and rescue work. It is strictly prohibited to work blindly without familiarizing with the site equipment. 2. Technically, electrical work should pay attention to the safety of the working environment. In the place of greater danger, should adopt the work method of total blackout. If it is not possible to work in total blackout, safety measures must be put in place. If the distance between the human body and the electrified body is less than 0.35 meters, or more than 0.35 meters, and less than 0.7 meters without isolation, spacing work may touch the charged body, insulation measures must be used. Insulated partitions, baffles, and other screens here. The next point of knowledge will soon tell you. Insulated gloves must also be worn when working. 3. Organization. Electricians working with electricity must be equipped with 2 people. One of them to work. One person is responsible for safety supervision. The electrician must be trained and qualified electricians to serve as. The guardian must be an experienced electrician. And uninterrupted supervision of the operator. Correct unsafe actions at any time, although this is a common. Low voltage electricians' work is not on the power grid. But failure to follow the rules and regulations can still cause serious accidents. This section concludes with a look at screen guarding. This section is relatively simple. It's also easier to understand. The concept of screening is the use of shields, shield, cover, boxes, etc., to isolate the dangerous electrically charged body, isolated from the outside world, to prevent the human body from touching or approaching electrocution caused by the human body touching or approaching the electrically charged body. For example, at home, there is a weak electricity box. There is a plastic cover on the outside, separates the electrified part inside from the outside world. This cover can be regarded as a shield, in addition to isolating the risk of electric shock. In addition to isolating the risk of electric shock, can also play a role in preventing arc injury. Prevent arc short circuit or facilitate the role of maintenance. Screen protection can be divided into 1. Shielding and barriers. For example, the cabinet of the high voltage switchgear is shielded, and the transformer is installed around the fence. It is difficult to climb over. This is the barrier. 2. Permanent and temporary screening. The switchgear cabinet. The switchgear cabinet is configured at the factory. This is the permanent type of fence, and the temporary fences that are put up during the work. Removed after the work is done. That's the temporary fence. The third category is divided into fixed and mobile. For example, as stated in the technical measures, installation of shelters. This is a mobile shelter. The safety conditions for screens are: 1. The materials used for the screening device should have sufficient mechanical strength and good fire resistance. For screen guards made of metal materials, the screen must be reliably earthed. 2. The protective guards shall be of sufficient size. The necessary distance should be maintained between the screen and the electrically energized body. For example, the height of the screen barrier indoors should not be less than 1.2 meters. Outdoors should not be less than 1.5 meters. Bar spacing should not be greater than 0.2 meters. 3. Screening. Fences and other devices should be stop, high voltage danger signs, etc. 4. When necessary, should be used in conjunction with audible and visual alarm signals, and interlocking devices should be used where necessary. Okay, this section to prevent direct personal electric shock. Basic measures to prevent direct personal electric shock spacing and screen protection is finished. We'll see you next time.